Hello everyone. Today we will use Edge Lambda for dynamic content delivery. Edge Lambda enables you to run custom code at the Edge servers around the world, closer to your users. It reduces the latency between the start of and end of the request. It's basically a CDN for your runtime. Let's start by taking a look at our design diagram. We have our client which sends request to route 53 to our domain. We host our domain on route 53 service, and we need to configure our DNS settings for a record to point to CloudFront distribution. Then a request will arrive on the network of Amazon CloudFront, and depending on the distribution behavior, requests will either be forwarded to Edge Lambda for dynamic content delivery or directly hit the S3 bucket. We will see the distribution behavior later in the video. Now I want to explain our use case for the Edge Lambda. Today we will use Edge Lambda to perform an IP lookup on the incoming request. If the request is originated from USA, Edge Lambda will allow CloudFront to forward the request to origin bucket, serving the web application, aka index.html. However, if the request is originated from outside of USA, the Edge Lambda will return a simple text message directly to the client. Advantages of this: you won't be charged for the request and data transfer cost if incoming request is from outside of your target business area. The assets of your application, such as chunk.js or image files, won't even be requested. By centralizing redirection logic within our Edge Lambda, we aim to improve web vitals and user experience. It is also important to mention the limitation of Edge Lambda. With Edge Lambda, you can't define environment variables. Thus, we had to use parameter store service to retrieve our secrets in our application. The other limitations are the maximum size of Lambda is 50 megabyte, including dependencies, and Lambda should be deployed to US East 1 region. You can learn more about the limitations by Googling. To summarize our approach, we serve our static site in S3 without paying for compute time, and we generate our static site using Next.js framework. We leverage CDN for our assets, and we also able to execute custom code at edge location without giving up performance. Now we can move into infrastructure definition. We use Cloud Development Kit to provision our infrastructure on AWS. Our choice of language is TypeScript, and our starter file located in the bin directory. Our application deploys single stack, and our stack consists of constructs. We use constructs to create separation logic. Separating the concerns will help you greatly to maintain your infrastructure as your application grows. In this application, we only have Lambda construct and storage construct, but you can create constructs as your need. For example, it can be called API construct, or it can be called compute construct for your EC2 instances or Docker containers. And if we look at our storage construct, we create a single bucket called side bucket, and we configure this bucket so it can be publicly accessible, and we enable website hosting. We also create a string parameter in parameter store to store our IP geolocation key. We will provide this key while making the AJAX call to IP geolocation API. In our Lambda construct, we only have one Lambda definition, and it's called IP checker Lambda. And since our code is written in TypeScript, it needs to be compiled to run by Node engine. And for this, we are using popular Node.js function module, and it uses ES-build under the hood. And we are forcing Docker bundling to prevent operation system incompatibility. So make sure to launch your Docker desktop app in your machine before making deployment. Now we can move to our app stack. We first import our constructs and initialize them. After initializing them, we give our IP checker Lambda the permission that reads IP geolocation kparam, and this kind of utilities such as grant read function is really awesome. They always defined on this storage services such as parameter store, DynamoDB table, and they are really handy. Next, we define our client front origin from our side bucket, and we have two policies that is defined for our client front distribution. One is cache policy and other is response policy. While I am in development stage, I always give value 0 to time to live params to not deal with hassle that creating distribution invalidation. For the response policy, we enable cross-origin resource sharing, and you can add custom headers while sending viewer response if you want. At last, we arrived on CloudFront distribution definition. We have two distribution behavior. One is default behavior and other is for index.html. Both of them takes side bucket as origin. We associate IP checker Lambda as edge Lambda for the index HTML behavior, so it can be invoked before reaching the index.html resource. We also modify 404 responses. What this does is, if access resource is not found on the origin, aka side bucket, we will serve index.html, our endpoint for the app. Next, we have CloudFormation output. CloudFormation output is really helpful when you want to print URL or IRN of the services. And we can move on to IP checker Lambda. Important thing to mention here, it only imports SSM client from AWS SDK instead of importing whole module. What I mean by importing whole module is you typically see import everything as AWS from AWS SDK, and then you can access any client as your need. But this is not encouraged in, or this should be your go-to case using Edge Lambda. Because of the 50 megabyte size limit, you only need to import the clients that you need. Another important configuration that we need to make is when using the any SDK service, we need to explicitly define the region our app stack is deployed. In our case, it's US East 1. If you don't explicitly specify the region, Lambda will access the service in the same region it's called from, which ends up throwing error. For example, let's say you didn't define your region, and user from London calls Edge Lambda. Edge Lambda will run on London region and try to access parameter store on London region, which doesn't exist, and your Lambda ends up with error. So you keep in mind to always define your region. Next, handler body. If IP geolocation key is undefined, it will retrieve it from parameter store and save it the outer scope, so it can be used on subsequent calls without needing the hit parameter store. And it makes Ajax call to IP geolocation API to learn country IP belongs to, and decides whether to return a simple text message or allow CloudFront to proceed with the serving the index HTML file. Let's also give a quick look at our front-end directory. Then we're gonna make deployment to our side bucket. We are using Next.js 13 with new app directory. We have 2 pages. They are very simple, and we enable static site generation in next configuration by defining output export. My IDE shouts me something is wrong, but I will look at it later. And we first need to build our front end. Before the deployment, let's run npm run build. Next.js finished building. It created 2 static pages for us. One is root and other is called other page, and our build directory is called dist, and we need to deploy our this directory to our side bucket. For this, I have a script command deploy -s3. We use AWS CLI to sync our this directory with bucket. This is the S3 URI. I will show you how can you access it, but before it, let's also mention what delete flag does. It will delete the assets from bucket if they don't exist in your this directory. So every time you make you make a deployment, it will remove the unnecessary chunks and your bucket won't be polluted. We also have profile flag in here. You need to specify your own AWS named profile for its value. Let's see our CloudFormation template. This is the template that belongs to our project. When we open the resources tab, we can see all the deployed resources. For example, you can access site bucket from here, and you can access IP checker Lambda directly from here instead of opening the Lambda console and searching through your Lambda definitions. In the outputs tab, we have CloudFormation outputs. We need to copy our S3 URI and paste it in our package.json script and run the deployment. It should be quick. Yeah, since I made previous deployment and nothing changed, it didn't do anything. After the successful deployment, we need to test our index.html, and it sends the text message because I'm outside of the USA region. Now let's activate our VPN, and it directly served me the index.html successfully. And we tested our Lambda. I hope you learned something from this video, and see you next time.